So far in the system design series, we've been laying foundation. We've covered the how of the internet. We tackled latency and why every millisecond matters. We looked at the bandwidth and pipes that move our data. We even went under the hood with TCP and saw how HTTP handles the heavy lifting of the application layer. But now it's time to move from how to what. Here's the real question. When the mobile app in your hand communicates with a massive backend server, what exactly are they saying to each other? They aren't just shouting random bits into void. They are following a strict set of rules, and that interface, that digital contract is called an API. Think of an API or an application programming interface basically like a waiter in a busy restaurant. You, the customer, are the front end. You don't walk into the kitchen yourself. You basically ask the waiter. So the front end says, hey, give me the user 123, and the API translates that into a database query, and the database responds, and the API sends the result back to your application. But here's the thing, if you design your API badly, you're building a house of cards. Bad design creates scaling problems, security holes, and backward compatibility nightmares. So let's build this properly. Most modern systems use a standard called REST. It just means one thing, design your APIs around resources. To do that, we follow the four golden rules. First is use nouns and not verbs. Next is statelessness, that is, every request must stand on its own. This is how you scale horizontally. And the third is a proper HTTP methods: get to fetch, post to create, put or patch to update, and delete to remove. And the fourth is the correct status codes. Speak the language of the web. 200 is for success, 400s are for client errors, and 500s are for server meltdowns. Now, APIs evolve, but old applications don't update instantly. So if you break your old API structure, you lose users. This is why we use version. The most common strategy is URL versioning, that is like API slash version 1 slash users to API slash version 2 slash users. So the golden rule here is that never break the existing clients abruptly, deprecate slowly, and communicate clearly. One other important thing we should remember while writing APIs are we should never try to return 1 million users in a single API response. So basically it overloads memory, stresses the database, and increases latency. Instead, we should paginate. So there are two kinds of paginations. One is offset based and one is cursor based. So offset based is something like offset equals to 20 and limit equals to 10, for example. Then it means that we skip 20 records and return the next 10. This is simple and easy to implement, but at large page numbers, the database still scans everything before it, which makes it slow at scale. The next is cursor based. Say, let's say we have cursor equals to ABC123, for example. So instead of counting pages, we continue from a specific position. So we are not doing a full scan. This is more stable and much more scalable. That's why high scale systems prefer cursor based pagination. And remember that pagination isn't just organization, it's database survival. And suppose what happens if one user sends 10,000 requests per second? So your system collapses, right? To prevent this, we use rate limiting, specifically the token bucket algorithm. Users get tokens that refill over time. If they run out, the API rejects them with a 429 too many request status code. This protects your infrastructure from abuse and accidental overloads. To secure our API, there is a fundamental distinction you must understand. Never confuse authentication with authorization. Authentication is all about identity. Basically, who are you? It's the hotel front desk checking your ID. Authorization is all about permissions. It's about what can you do. It's your key card only letting you into your room. You need both to keep an API secure. In the real world, we use OAuth for secure delegation, like logging with Google, and JWTs, that is JSON Web Tokens, to pass the identity around statelessly. And JWTs are signed and scalable, making them perfect for microservices. Just remember to use expiry times. Finally, we have to talk about backward compatibility. If your API update crashes an older version of your app, you've failed the contract. Safe changes are more like adding fields or making them optional, and dangerous changes are like removing fields or changing data types. Additive changes are safe, and breaking changes require versioning. So, how does the big companies think? When companies like Google, Netflix, or Amazon design APIs, they aren't just thinking about the code. They operate under a completely different set of assumptions. They assume millions of clients hitting the servers at once, dozens of different app versions running in while simultaneously, network failures that are guaranteed to happen, malicious traffic trying to find a weak spot, and partial outages where one service dies while the others live. API design is not just about creating endpoints, it's about building for long term evolution. So today we've covered REST principles and resources, versioning and backward compatibility, pagination and rate limiting, authentication versus authorization, OAuth and JWTs. And this is what separates hobby projects from real world production systems. If you can master these design patterns, you're ready to build systems that can scale to the moon. I'll see you in the next one.